Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Dissonance by Vitre, and here are the rules. We have normal Sudoku rules apply, which is place the digits 1 through 9 in every row, column, and 3 by 3 box. And digits in a cage sum to the small clue in the cage's top left corner, and digits may not repeat within a cage. So, for example, if we had, where's a good example here? A 3 here, this would have to be 9. Because these two digits must add up to 12 because they are in the cage, the only two digits in the cage, which has 12 in the upper left-hand corner. And those are all the rules. This is a simple killer cage Sudoku. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, two digits adding up to... Where should we start? 3. It has to be 1 and 2 adding up to there for 2 digits. For 2 digits adding up to 4, it's 1 and 3. 2 digits adding up to 17, it's 8 and 9. 2 digits adding up to 16, it's 7 and 9. So we have a guaranteed 9 in rows 7 and 8 in these two cells. We have a guaranteed 9 in rows 7 and 8 in these two cells. That eliminates 9 from the rest of rows 7 and 8. So where can 9 be in this right central box? It cannot be in row 7 or 8. It has to be one of these 3 digits. And for 3 digits to add up to 22, the possibilities are 5, 8, and 9 for 3 digits, and 6, 7, and 9. Well, they both require 9, so where's the 9 in this cage? It must be here. And we have a similar setup in rows 1 or rows 2 and 3 because we have a 1 guaranteed here and a 1 guaranteed here. To add up to 8, we have to have 1, 2, 5 or 1, 3, 4. And this cannot have a 1 in it because we have a guaranteed 1 in those. We have 2 guaranteed 1s in both of those rows already. So 1 has to be here. Okay, to add up to 8, it's either 1, 7, 2, 6, or 3, 5. Well, 1, 7 is eliminated already. Therefore, this has, and to add up to 8 here, it's either 2, 5, or 3, 4. Well, 1, 2, 5 would eliminate 2, 6, and 3, 5 to add up to 8, and we already have the 1, 7 eliminated, so there would be no possibilities for this cage here if this is 2, 5. So this must be 1, 3, 4, which eliminates 3, 5 as a pair, which makes this a 2, 6 pair in this cage here. And it's the same thing with this because this is symmetrical in a sense, because these are the digits that are the highest digits, and these are the digits that are the lowest digits. If you notice, 3 and 17 are the smallest and largest sums you can ever have for 2 digits. 4 and 16 are the second smallest and second largest sums you can have for 2 digits. 22 is the third largest sum you can have for 3 digits, and 8 is the third smallest sum you can have for 3 digits. To add up to 12, you have for 2 digits, again, it's 3 is 5 or 6 sets away from 8, and 12 is 6 sets away from 17, right? You have 17, 16, 15, 14, 13, and 12. That's a 6 set away. And you have 3, 4, 5, 6, 7, and 8, which is also 6 sets away. So this is a similar situation. We cannot have, it's either 5, 8, or 6, 7, but to add up to 12 here, if we have 5, 8, that eliminates, we already have 3, 9 eliminated, 4, 8 would be eliminated, and 5, 7 would be eliminated, and we have no possibilities here. So it cannot be 5, 8, it's 6, 7 there, which forces this to be 4 and 8 as a pair, remaining in column 9. Okay. Where do we start? Where do we continue? That is the question. Let's do these sets. And it's correspondingly these because these are similar to these sets, right? Remember 3, 4, and 5 is the third set away. 17, 16, 15 is also the third set away for that. And then down to 14 is 4 sets away, up to 6 is 4 sets away. So these are basically symmetrical for these scenarios. The only symmetry we don't have is here. So keep that in mind. For 3 digits, 12 is how many sets away from 6? 6 is the least. 6, 7, 8, 9, 10, 11, 12 is 7 sets away. Oh, that's different. So this is not symmetrical there. Interesting. 6 is 4 sets away from 3, and 14 is 4 sets away from 17. So those are symmetrical. The 20 in 12 are not, though, so keep that in mind. So we'll keep working with the symmetrical sets. So 5, you have 1 and 4 and 2 and 3 adding up to 5. For 6, you have 1 and 5 and 2 and 4 adding up to 6. Well, if we try to have 2, 4 here, that would eliminate 1, 4 and 2, 3 in this 5 cage here. And that's not allowed because we would not have any possibilities now for this cage. So this can't be 2 and 4, it must be 1 and 5. Which means this can't be 1, 4 adding up to 5 because of the 1, 5 pair in the row. So this must be 2, 3. So this has to be the same thing. This must be 5 and 9 adding up to 14. And this has to be 7 and 8 to add up to 15 there. Well, where is 5 in row 5? It cannot be here because we have a 5, 9 pair in the box. Can't be here because of a 1, 5 pair in the box. Can't be here or here because to add up to 15 with 2 digits, it's at minimum 6, 6 and 9. And can't be here because at maximum, you could have only a 4 adding up to 5. So 4 and 1 could add up to 5. So whereas the 5 in row 5, it has to be there. Therefore, these 2 digits must add up to 10. Well, that's not that helpful. Anyways, let's continue. Well, that's a symmetry around there. This is 7 and 9. 1 and 3 eliminates 1 and 5 here, so this is 2 and 4. As a pair, same with that. 7 and 9 eliminates 5 and 9 there, so it's 6 and 8 as a pair. We have 6, 7, 8, 9 there. We have 1, 2, 3, 4 here. Okay, remaining digits of column 7. We have 5 through 9 left because we have 1, 3, and 2, 4 as a pair. So 5 through 9. This cannot be 5 because of the 1, 5 pair in the box. This can't be 7, 8 because of the 7, 8 pair in the box. So this is a 6, 9 pair. That eliminates 6 and 9 in the rest of the column. This can't be 8 because of the 4, 8 pair in the box. So we have 5, 7, or 8 here. This can't be 7 because of the 6, 7 pair in the box. Interesting. So we should have something similar here in column 3. So we have 1 through 5 there. No 1. This can't be 5 or 2, 3 because of the 2, 3 pair and the 5, 9 pair in the box. So this is 1, 4 as a pair. That eliminates 1, 4 in the rest of the column. This can't be 3 because of the 3, 4 pair in the box. This can't be 2 because of the 2, 6 pair in the box. And this cannot be a 2. So this is not this is where the symmetry breaks for this puzzle. This digit cannot be a 2 because if this was 2, 2 plus 2 unique digits is never adding up to 20. You're adding up to at most 19. 2, 8, and 9. So this can't be 2, which makes this a 5. 5 eliminates 5 here, so it's 3, which eliminates 3 here, so it's 2, which eliminates 2 there. So that's a 3. 5 eliminates 5 here, so that's 7. No 7 here, so that's 8, which makes that not 8, so it's 7. 8 eliminates 8 here, so that's a 5. So to add up to 20 with a 5, that means the other digits must add up to 15, which is 20 minus 5. And we don't have a 7 available, so this must be a 6-9 pair. This can't be 6 because of the 6-8 pair in the box. So this is 9, and that's 6. 6 eliminates 6-9 as a pair here, so this is 7-8 as a pair. 7 and 8 with 2 and 3 add up to 10. And this must add up to 10 because these have to add up to 15 because we have 15 here and 15 here. 40 minus 15 times 2 is 30. So 45 minus 30 is 15. And 15 minus 5 is 10. So this must be 2 or 3, which makes that a 2 or 3 possibility there. Okay. 9 eliminates 9 here, so this is 5 and 9. Remaining digits of this upper left-hand box are 2 and 7. Where is the 2 available in row 1? Cannot be here because of the 1-2 pair in the box. Can't be here because of the cage, so it has to be here. So that's 2. We don't have something similar here because it's not... Remaining digits of row 1 are 3, 4, and 8. This can't be 3 because of the 2-3 pair in the column, so 3 has to be here. Okay. Remaining digits of this left central box are 6, 7, and 8. And these can't be 6 because of the 2-6 pair in the column. So 6 has to be there. So now we have, what, 7 and 8? Since this is a 7-8 pair, the remaining digit in column 1 is a 5. And 6 eliminates 6 here, so that's 9. To add up to 15 here, you can't ever have 4, because 4, 6, and 7 at minimum adds up to 17. So this has to be 1, 1, 6, and 8 add up to 15 here. 8 eliminates 8 here, so it's 7. 8 eliminates 8 here, so it's 7 and 8. 1 eliminates 1 here, so it's 4. These 3 digits add up to 10, or these 2 digits add up to 10 because these 3 add up to 15. So it's 7, 5, and 3, which makes that a 2. Remaining digits here are 2 and 4. This can't be 4 because of the 4-8 pair in the column, so that's 2, which makes that 4. 9 eliminates 9 here, so it's 6. Remaining digits of column 2, we have 1, 4, and 8. Adding up to 13, remaining digits we have here in row 4 are 4 and 9. And this can't be 9 because of the 8-9 pair in the column, so this is 4, which makes that 9. That makes this 4 and 9 adding up to 13. 4 eliminates 4 here, so it's 8, which eliminates 8 there, so it's 4, which makes that 8. 4 eliminates 4 here, so that's 3 and 4. 3 eliminates 3 here, so it's 1 and 3. 1 eliminates 1 here, so it's 2 and 1. 2 eliminates 2 here, so it's 7 and 2. 8 here eliminates 8 here, so it's 6 and 8. Okay. Remaining digits of the central box are 1 and 6. This can't be 1 because of 1 in the column, so that's 6, which makes that 1, which leaves a 3 remaining in row 6. That leaves a 1-5 pair remaining in column 9, but this can't be 1 because of 1 in the box, so this is 5, which makes that 1, which makes that 5. These add up to 12. 12 minus 5 is 7. So we have to have 2 digits adding up to 7 here. There's no 3 available because of 3 in the row. There's no 2 available because of 2 in the column here, and the 2-4 pair in this box here. So this has to be 1 and 6 here as a pair. That eliminates 1 and 6 in the rest of the row. which means this can't be 6. That's 2, which makes this 6. 1 can't be here anymore because of 1 in the row. This can't be 6 because of the 6, 7 pair in the box, so this is 1, which makes that 6. Remaining digits. Let's go through row 3. We have 6 and 9 remaining. This can't be 6 because of 6 in the box, so that's 9. That's 6. Remaining digits in this left upper right-hand box is 9. Remaining digits in row 2 are 5 and 7. This can't be 7 because of 7 in the column, so that's 5, which makes that 7. Remaining digit in column 5 is a 7. So remaining digits here in row 9 are 4 and 8. No 8 here because of 8 in the column. So that's 4, which makes that 8. So no more 8 here. Remaining digits of column 4 are 2 and 3. That doesn't help. Remaining digits of column 6 are 1 and 5. This can't be 5 because of 5 in the row. So that makes that 1 and 5 there. 1 eliminates 1 here, so it's 4 and 1. 4 eliminates 4 here, so it's 2 and 4. 2 eliminates 2 here, so it's 3 and 2. We have a 6 here anyways. 6 eliminates 6 there, so it's 7 and 6. Makes that 9 and 7. Makes that 8 and 9, which leaves us an 8 here and a 3 here. And that's the solution. Yep, pretty straightforward Killer Cage Sudoku. If you're at all familiar with Killer Cage Sudoku, this should be very straightforward in its solve. Even if you haven't experienced Killer Cage Sudoku, this is just a lot of basic math and just figuring out what the possibilities are and where they can't be. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.